So section 5.4, the fundamental theorem of calculus. Let's check how it's going to be the theorem. If a function f is continuous on a closed interval a, b, and f, capital F, is the antiderivative. That means the integral of the function f. If f is a function continuous on the closed interval ab, and capital F is the antiderivative of f, then the integral from a to b. Now we have boundary here. Our integral from a to b, it's a definite integral to the function. That means the first thing you're going to find the integral, the antiderivative of x. The first thing you're going to find the antiderivative for x and your boundary from a to b. So that's the first step. You're going to find the integral for the function f of x, and here is your boundary from a to b, and then you're going to plug in. And be careful. When you plug in, you're going to plug in b first from the top, then you're going to plug in a. That's why we're going to get f to the b minus f to the a. So that's the fundamental theorem of calculus. So it's called the finite integral. The finite integral. So they're going to ask you to evaluate, and here's your integral. And you see the boundary from 0 to 4, 3t minus 1 to the dt. We need to evaluate this one. So what's the first step I have to do? I have to find the integral for 3t minus 1 squared with respect to the t. I'm going to say, before I'm going to start, I can simplify this one. 3t minus 1 squared. So on the side, I'm going to say it's a 3t minus 1 times 3t minus 1. That's mean 3t times 3t is going to be 9t squared minus 3t minus 3t plus 1. Combine the log terms, so it's 9t squared minus 6t plus 1. That means this one is exactly the same, the integral from 0 to 4 to the 9t squared minus 6t plus 1 to the dt. So you see, our first goal is to simplify this one, and then I need to find the integral for 9t squared minus 6t plus 1. That means this one is going to be equal. The integral for the first one, 9t squared, is going to be 9t cubed over 3. Minus the integral for 6t, because here's the thing. I'm going to find the integral for the first term, the integral for the second one, the integral for the third one. I don't have to split these. I'm just going to do it right away. The integral for the first term is 9t cubed over 3. Minus the integral for the second one is going to be 6. And t is going to be squared over 2. The integral for 1 is going to be t. The only difference is we have boundary from 0 to 4. From 0 to 4. I'm going to write down the boundary here because I don't have integral anymore. So here's my boundary from 0 to 4. Next step, by using the fundamental theorem of calculus, we're going to plug in 4 first here. After we simplify, then minus plug in the 0. Let's simplify first. You can simplify these, so it's going to be 3t cubed. The 6 with the 2 is going to be minus 3t squared plus 0 to 4. Now that's a plug-in. You're going to plug in the 4, and then plug in the 0. Be careful here. Always you're plugging the top in the bottom. If you do the opposite thing, it's going to be wrong. So it's going to be 3, 4 cubed minus 3, 4 squared plus 4 minus. Plus 4, so to be minus, you're going to plug in the 0. Which is a 3, 0 cubed minus 3, 0 plus 0. Check here, everything is going to be 0. Now, let's simplify this one. This one's going to be 381, 192. And here's 16 times 3 is 48 plus 4. Tell me, how much is going to be the result? 148. 148. 196 minus 48, 148. So you see, we're doing exactly the same thing, but we're gonna add, we have boundary from 0 to 4. And of course, the first step, you have to find a way to find the integral. I can't find the integral here, so I can distribute this one. Yes, because it's 2 binomials, and then find the integral for each term. I have boundary from 0 to 4. That's why it's called the finite integral, because we have boundary, and we're going to use the same steps to find the area. Here, our next example, which is evaluate the finite integral from 1 to 4, the square root of 3 over x dx. I'm telling you, the important thing here, you have to know how to find the integral. So you can say, how am I going to find the integral for this one? Before I start, it's the square root of 3 over x. So does that mean this one is equal, the same thing, from 1 to 4, square root of 3 over square root of x dx? Can I write down this? Square root of 3 over square root of x. Can I do that?
Yes.
So this is the first step. Now, you see, I'm telling you, the important step is how we're going to find the integral. Now, square root of 3 is a constant, is a number. So can I take it out, the integral? Yes, because remember, we have a rule that says, if you have the integral from ax dx, you can take the a out, so it's the same thing, the integral of x dx. So I'm going to check, because this is a constant, so this one is going to be square root of 3, the integral from 1 to 4, 1 over square root of x dx. Now, next step, what I'm going to do, let's say, okay, this is, everything is right. Can I convert this one to a rational exponents?
2.5.
So half, yes. So you can keep this one, you can convert it to 3 to the half, it's fine. So square root of 3, integral from 1 to 4, I'm gonna say it's 1 over x to the half dx. Then I'm gonna check the x to the half to the top. So it's going to be negative half. That means square root of 3, integral from 1 to 4, x to the negative half dx. Now what about the 3? Just keep it until the end. Square root of 3, keep it until the end. Now, can I find the integral here? Yes, I'm just going to add 1 and divide by the result. So this one is going to be square root of 3. We're going to add 1. So negative half plus 1 is going to be half divided by half. That's mean it's going to be x to the half divided by half and the boundary from 0 to the 4. That's what to go, yes. Here is going to be square root of 3. I can write down this, flip it to the top. So it's going to be 2. 2, and here is x to the half from 1 to 4. If you want to keep it here, it's fine, because next step is just going to plug in the boundary. So plug in 4. That's me. Here is the 3. Plug in the 4 here, so it's going to be 2. And here is 4 to the half minus plug in 1. It's going to be 2 and 1 to the half. Now it's going to be square root of 3. 4 to the half. Does that mean the same thing, square root of 2?
Yes.
You can plug in the calculator, but 4 to the half, which means the square root of 4, which is going to be 2. That means it's 2 times 2 minus 1 to the power half is going to be 1 times 2 is going to be 2. That means we can get square root of 3. 2 times 2, 4 minus 2. So 4 minus 2. And then it's going to be square root of 3. And 4 minus 2 is going to be 2. That means the result is going to be 2 square root of 3. You got it? So the important thing, how we're going to find the integral. That's the important thing, because when you plug in, you're just going to plug in the top 4. Then minus the bottom is going to be, that's the easy part, because you have to be careful always the top, then the bottom. Thinking about how I'm going to find this, the integral. So can I say this one is equal the same thing? Integral from 1 to 9, u divided by square root of u minus a divided by square root of u. Can I do that? Because this is a denominator for u and for the 8. So I'm just gonna split these two. Next step. Square root of u. Is that u to the power half? So what I'm going to do, I'm going to say, okay, it's the integral from 1 to 9. For the first term is u over u to the power 1 over 2. And the same thing here, it's minus 8 to the power to the u to the power half. Everything du. Now, is that easier? What do you think? Can I use the exponents rule here? Here, the same base, the exponents here is 1. If I have division between two base with different exponents, but the same base, I'm going to say top minus the bottom. It's a rule. It's one of the exponents rule. It says if you have a to the power m and a to the power n, the same base, and here's the exponent, is going to be a m minus n. They do the same thing here. So this one is going to be the integral from 1 to 9. The same base is going to be u. 1 minus half going to be half. Minus. What about this one? Here the 8. Can I move this one to the top? So it's going to be 8 u to the negative half. And everything u. Now this one is easier to find the integral. I'm going to find the integral here, and I'm going to find the integral here. So here you're going to add 1. That means it's going to be u half plus 1 is going to be 3 over 2. That's mean is going to be u 3/2 divided by 3/2 minus, keep the 8, the integral for negative half, so minus 8. The integral for negative half, you're going to add 1, so it's going to be u to the half over 1/2. And the boundary from 1 to 9. That's it, we're done from integral. Next step, we just have to simplify. I'm going to move this one to the top. So it's going to be 2/3 u to 3/2 minus 8. Move this one to the top. So times 2 u to the half, and from 1 to 9. That means this one is going to be equal 2/3 u 3/2 minus 16 u to the half from 1 to 9. What's the next step?
Plugging the valuation.
Plug in.
Fine.
So the first thing we're going to start from the 9. I'm telling you, you have to be careful here when you plug in the numbers. Plug in the 9. So it's going to be 2/3 times 9 to the 3/2 minus 16 times 9 to the half. Here's minus. Minus this one between the two integrals. Plug in the 1. So it's going to be 2/3 1 to the 3/2 minus 16 and 1 to the. Now let's look here. Here. 9 to 3/2. It's going to equal what?
27.
27. How you did that?
You took the square root and cubed it.
Perfect. Because 9, the 2 is a square root. So I can take square root for 9 is going to be, let's do it here on the side. 9 to 3/2 is the same thing. The square root of 9 cubed. The square root of 9 is 3. 3 cubed is going to be 27. That means this one is going to be 2/3 times 27 minus 9 to the half is square root of 9, which is equal to 3. 3 times 16, that's 48. So I'm going to write down 16 times 3, so you can know. Minus 1 to any exponent is going to be 1 times 2/3. So it's going to be 2/3 minus 16 times 1 is going to be 16. Next step, 2/3, simplify these is going to be 9. That means 2 times, I'm just going to just do that away. 2 times is going to be 18 minus 16 times 3 is 48 minus 2/3 plus 16. How much is going to be the whole result? Combine the numbers is going to be, I have negative 44, I'm not sure. Over 3? Yes, because we have a 3. Negative 44 over 3. So let's find the defined integral from 0 to 3, the 3 minus t, and square root of t. So what's the first thing? Our first step you have to do. We're going to distribute the square root of 3. So I'm going to say this is equal to the integral from 0 to 3 is going to be 3 square root of t minus t square root of t dt. Now, next step, but if you look here, it's the same base, but I need to convert the t to exponents. So the same thing here. So I'm going to say it's the integral from 0 to 3. It's 3t to the half minus t, and here is t to the half dt. One of the exponents rule, if you have the same base and there's multiplication, the rule says if you have a to the power n times a to the power n, same base, different exponents, you're going to just add the exponents. So you're going to do the same thing here. 1 plus half so this one is going to be the integral from 0 to 3, 3t to the half minus t, 1 plus half is going to be 3 over 2, everything dt. Now this one is easier to find. The integral, you're going to add one here, and you're going to add one here, and divide by the new exponents. So it's going to be 3t to the 3 over 2, 3t, 3 over 2, and divide by 3 over 2, minus t, 3 over 2, add 1 is going to be 5 over 2. That's going to be t, 5 over 2, divided by 5 over 2, from the boundary from 0 to 3. This is going to simplify it. This one is going to be 3 times 2 over 3. But I'm going to flip this one. T 3 over 2 minus 2 over 5. T 5 over 2, only from 0 to 3. Yes or no? What's the next step? Simplify this one. So it's going to be from 2t 3 over 2 minus 2 over 5 t 5 over 2 from 0. Now we don't just plug in the 3. So it's going to be 2, the 3 over 2 minus 2 over 5 and the 3, 5 over 2 minus, plug in the 0, 2, 0, 3 over 2 minus 2 over 5, 0, 5 over 2. 0, 0, everything here is going to be 0. Now, for this part, how much is going to be?
Radical 6 square root.
What is it again?
6 square root of 3.
6 square root of
3.
3. Why? Because what do you did? Did you cube it?
So what I do is I change it to the square root line.
Okay.
I like to see it.
Okay, it's fine. So you're gonna say it's square root of what you did. You change it to the root, the ratio.
Yes, I change it to the root,
How?
which is 3 to the cube,
3
and
cube.
then
square
all
root.
of it squared here.
Okay. So that means going to be square root of 27, which is 3 square root of
3.
3. Yes, you can do that, right? That means it's going to be 2 times the 3 square root of 3 minus, can we do the same thing here? This one is going to be what?
It's gonna be the square root of 3 to the power of 5.
square root
of
of
3.
3 to the power 5. Yes. Square root of 3 to the power 5, which is mean square root of AU1 times 3. Yes or no? The square root of AU1 is 9. So 9 square root over 3. That means this one is going to be minus 9. Don't forget this one. 2 over 5 times 9 square root of
3.
3. Now, how are we going to combine these together? It's going to be 6 square root of 3 minus 18 over 5 square root over 3. Then you're going to say this is over 1. We need to find the common denominator. So multiply this one by 5. By 5, and multiply the 1 by 5. That's mean is going to be 30 square root of 3 divided by 5 minus 18 square root of 3 divided by 5, which is equal 12 square root of 3 divided by 5. Got it? Have the same result? So now they ask you, find the area of the region bounded by the graph of y equal 2x squared plus x plus 2 and x equals 0, x equals 3, and y equals 0. So they're telling you it's bounded by this graph, which is a curve, and by these boundaries. X equals 0, x equals 3, and y equals 3. So the first thing, I need to graph the curve. So that's my goal, because I need to graph which area I'm going to find. So to graph the curve, which is y equal 2x squared plus x plus 2. What I'm going to do, let's check my x's. You see x equals 0, that means this point and this point. The area with the x coordinate, I need to find between x equals 0 and x equals 3. Let's check the next part. So what I'm going to do, I'm going to say, okay, let me graph simple table. Here is the x and here is the y. When x is 0, I'm going to plug in zeros here. 0 and 0. The y equal 2. That means when x equals 0, y equals 2. So my graph start this. It's a 1, 2 from here. The curve starts from this area, from x equal 2. So the first point is 0, 2. If you plug in a 3, 2 times 9 going to be 18. 18 plus 3 plus 2, so 23. That's me. 2, 3, sorry, 23. At the point 3, going to be 23. So at the point 3 is going to be, let's say here's 23. This means going to be here. So I already know my graph. It's not a line. The graph is not a line, it's a straight line, because it's a curve. So what I'm going to do to make sure it's a curve, if I choose 1, 2 times 1 is going to be 2. 2 plus 1, 3. 3 plus 2, 5. So at point 1 it's going to be 5. 1, 5. 1 is going to be 5. The graph starts from here and go up like this. I'm not going to care. I need to find the area here. So here's my area. I need to find the area between this curve and the x. Okay, so next step, okay, you're going to say, but we're always going to find the area between the x or the y with the curve. In this case, we're gonna do what? Remember? The rectangles here, bounded is goes from x equals 0 to x equals 3. That's mean it's a definite integral from x equals 0 to x equals 3 to there. 2x squared plus x plus 2 dx. Because my rectangles is going to start from x equals 0 to x equals 0 to x equals 3. My rectangle is like this. It's moved from x equals 0 to x equals 3. So I'm going to do the integral with respect to the x to find the area. Now it's exactly what we did on the previous examples. So find the integral here, which is going to be 2 times x cubed over 3 plus x squared over 2 plus 2x, and the bound is from 0 to 3.
So I have a question. So those values you wrote down, like the x equals 0, no, the ones on the top, like the ones in no, the one in black, yeah, those are what? Like
These are the bounded. They're telling you from x equals 0, bounded between this graph
okay,
and x equals 0, x equals 3, and y. These are given.
okay.
Okay. So now we're going to plug in 3. That means it's going to be 2 times the 3 cubed over 3 plus 3 squared over 2 plus 2 times the 3 and minus, for the second part, you're going to plug in the 0, 2 times 0 cubed over 3 plus 0 squared over 2 plus 2 times 0. Check the second part, 0, the first term, 0, 0. So everything is going to be 0. Now this one, 27 divided by 3 is going to be 9. 9 times 2, 18. Plus 9 over 2 plus 6. 6 with the 18 is going to be 24 plus 9 over 2. Find the common denominator, multiply this one by 2. That means it's going to be 4/8 over 2 plus 9 over 2. And the result is going to be 5/7 divided by 2. So you see the area bounded between this curve and the x from 0 to 3, and the y from 0 to this curve equals 57/2. This is the exact area. It's exact area. It's not approximation. It's the exact area for this graph. Find the area of the region bounded by y equals 7x squared plus 4, and by x equals 0, x equals 2. That's mean x equals 0 from here to x equals 2. So here is my x for the area is going to be. For the y equals 0, start from here, and y equal the curve. So we need to graph this one. So I'm going to do the same thing. X, y, taking the 0, and here's the 2. And be careful, it's a curve, it's not a line. So when it's 0, plug in the 0 is going to be 4. That means the first point, 0, 4. That means start from here. Down 5. Second one, plug in the 2 here. So it's going to be 7 times 4, 28. 28 plus 4 is 32. That's mean is going to be 2, 3, 2. To go a little bit up more. Yeah. 2. Yeah. 7 times 4, 28, 32. So this is 25. This is 30. Oh. 32. So when x equal 2 is going to be 32 here. That means our curve is going to be like this. Here's my area. From 0 to 2. That means our integral. You can check if you're picking a number between 0 and 2, it's still like this. So our integral is going to be from 0 to 2. Because we're going to do the same thing. We're going to get the rectangles like this. From 0 to 2. If you want to work with the y, which is going to be hard, you have to take from 0 to this number, from 0 to. So it's going to hard because it's a curve. So we're going to take the rectangles with the x. And our function is 7 x squared plus 4.
When is it easier to work with y instead of
With y, if you have, I'm going to show you, if you have example different than this one. Like, let's say, like this. Even if you do like this, it's going to be, I'm going to show you another example. Because it's going to be double integral. So let's find the integral for this one, which is equal to 7x cubed over 3 plus 4x, and from 0 to 2. Then plug in the 2. So it's going to be 7 times 2 cubed over 3 plus 4 times 2. Everything minus. This one is 0 and this one is 0. So it's going to be 7 times 0 cubed over 3 plus 4 times 0. Everything here is 0. That's mean it's going to be 7 times 8 over 3 plus 8. It's equal 7 times 8, 56 over 3 plus 8. Multiply by 2 by 3, because this is over 1. So times the 3 times the 3. So it's going to be 56 over 3 plus 24 over 3. Yes or no? How much is going to be A over? So check here. We did 2 examples, and our example is bounded by x on a curve. What about if you need to find the area bounded by 2 curves? Let's say this is the first curve, and we have another curve like this. They're asking to find an area between 2 curves. Here's the first curve, and here's the second curve. We need to find this area. So in this case, it's going to be up to you. You want to do rectangles like this with the x, start from this point to this point, and from the y, this one, the start of calculus 2. You're going to find the area between 2 curves, like this one. Going to be double integral. Okay, that's why I'm telling you, you have to make sure before you take in how to do the integral, how to do the derivative, because that's your beginning is going to be able to.